All right, guys. Today I want to talk about transformations of quadratic functions in vertex form. Okay, so mainly this year, what we've been working with is when we've been doing quadratics, we've been working with them in standard form, right? So this is, sorry, I should write that on here. This is standard form right here. Okay, so this is standard form, right? And that's what we should be used to working with, right? Okay, right, we were defining A, B, and C. We use that for factoring, we use that for graphing, right? This is what we're going to call vertex form. And if you haven't seen kind of like where this is going, when we're completing the square, this is going to kind of be, if you remember what completing the square looked like, this is going to be kind of where we're going. So today we're going to start to really just tie up some loose ends with some things we kind of already know, okay? So in vertex form, I'll erase this because we're not really concerned with it right now. Okay. In vertex form, we've got a couple components. We've got A, negative H, and K. A is going to influence the following. Okay, well, we know this shape, that when we graph quadratics, they make a parabola, right? So they should make a shape that looks something like this right here, right? Make a nice parabola. The A is going to influence whether it opens up or down. And essentially how steep it is. We are not really worried about the steepness today. Okay, we're not like really worried about this. We'll talk about what it is, but for today, we're not really worried about how steep it is. We are more worried about negative H and K today, okay? So again, if A is positive, it's going to open up. It's going to look something like that. If A is negative, it'll look something like that, and it'll open down. Okay, so positive. So again, if you think about this, there's a smile, happy face is positive, sad face is negative. Okay, so we'll talk about that as we go through it. And the other thing, which you should remember from last time, is negative H and K. So you should remember negative H and K from when we did absolute value functions. We definitely did them there. When we did our radical functions, we definitely did them there. And we will do them again next year when we do circles. So please don't forget this, okay? Negative H and K. Negative H and K are the location of the location of the vertex. Location of the vertex. The one thing you guys need to keep in mind is that H has that negative sign in front of it, right? H has a negative sign in front of it, which means you have to flip, okay? You have to flip. If it's positive, it's going to become negative. If it's negative, it's going to become positive. Again, what does that really mean? A negative H really means negative 1H, right? So negative 1 times any number gives us the opposite, right? The additive inverse. It flips the sign of the number. So if H was positive times negative 1, it's the same number but negative. If H is negative times negative 1, same number but positive, okay? For all intents and purposes, all we have to do is remember that that is going to flip the sign, okay? So that's going to be the location of your vertex. So essentially, in relation to the parent function, which we'll show in a second, this is going to tell you how many spaces to move left and right, how many spaces to move up and down, okay? So again, negative H, it's going to control the left, right, but it's going to be flipped, okay? And the K is going to handle the up and down, okay? So let's take a look at the parent function. Let's kind of review what that means. So this is the parent function for any quadratic. This is f of x is equal to x squared, okay? So just to kind of foreshadow what we're going to be doing, when you start from this, it's 0, 0. Your vertex is at 0, 0. In either direction, all you really need to do is square the result. So I went 1, 1 squared is 1. I went 2, 2 squared is 1, 2, 3, 4, right? So 1 times 1, 1. 2 times 2, 4. 3 times 3, 9. 4 times 4, 16, right there, okay? And we just pretty much do that on both sides, okay? Now, A will affect that later. We'll talk about how that A is going to make that steeper. But for right now, that's our pattern. From our vertex, we go 1 over, square root, 2 over, square root. So 1, 1, 2, 4, 3, 9, 4, 16. And we do the same thing in the other direction. Negative 1, 1. -2, 4. Okay, so what's going to happen is we're going to move this parabola somewhere else, but we're still going to follow that same pattern. All right, so let's take a look now about what happens if we change these things. Okay, so for right now, we're going to keep a equal to 1. We're not going to mess with it at all. Okay, what if I change, I say x minus 5, x plus 4. Well, let's take a look at what happened. I went from being here, have my vertex at 0, 0, to my vertex here at 5, 4. Okay? Notice inside this was -5, right? So even though it says -5, we went in the positive direction. And +4, we went up 1, 2, 3, 4. So all you have to do is take a look at what's inside here and make sure you reverse that, okay? Other than that, though, everything is the same. Look, I went over 1, 1, 2, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? I still went to these same kind of points in here. Oh my goodness, if I could. So the numbers themselves have changed, but the pattern has not. Okay, the pattern is still 1, 1, 2, 4, 3, 9, 4, 16. So when we get things in vertex form, it tells us, very precisely where the vertex is, and then we can just follow that pattern from there. I'll show you what happens if we make a negative. In other words, if I throw a negative out in the front, take a look, watch the vertex, keep your eyes on the vertex, your vertex doesn't move, whether I make it positive or negative. So this negative on the outside here actually has no effect on these two numbers here. So all that you have to remember is if you wanted to reflect it, all you need to do is to make this positive or negative. Okay, so that's a horizontal reflection. I'm sorry. Vertical reflection. I'm sorry. Good? All right, so let's take a look at a few examples, and then I'll set you guys to it, okay? So what if I wanted the vertex to be, so say I wanted my vertex to be, I don't know, to be -7, 4, okay? So let's say f of x is equal to a, remember it's x minus h squared plus k. K is the easy part, k stays as 4, okay? The thing we have to remember here is because there's a negative here and a negative here, we have to flip that sign. So that's going to become +7 squared, okay? And I'm not really worried about the steepness right now, okay? So again, x plus 7 plus 4 should have a vertex of -7, +4. So we'll say x plus 7 minus 4. And again, what happened? It moved it -7. I'm sorry, it was +4. +4, right? So again, this number stayed the same. This number got flipped, okay? So I just want to show you guys some of the questions you might see on IXL today, and then I'll set you guys off. That's about all you need to know for today. Just remember, flip the number in here, keep the number out here. So if they gave you something like this, find g of x, where g of x is the translation 8 units up to f of x, okay? Don't get caught up in the nonsense. They just want to know g of x, f of x, two different functions. F of x is the parent function. All they want you to do is take this and move it 8 units up. So what are you going to say? Well, they said 8 units up, so we're not moving it all left and right. So that's staying the same. K is getting moved up 8. Okay, so what are we going to say? We put inside parentheses if we want. What do we say? Well, x didn't change, did it? But we want to move it 8 units up, so we're going to move it 8 units up. Okay. Here we want to use it, find g of x, where g of x is the translation 8 units to the left. Now, to the left is in the negative direction, right? But we need to remember, no, we're not moving in the negative direction. We want to flip that. We want to flip that to be positive. So what are we going to say? All this is going to be is x plus 8 squared, right? Okay. Find g of x, where g of x is the reflection over the x-axis. Well, how do we say we reflected it over the x-axis, all we had to do was go ahead and make a negative, right? So what are we going to say? Negative x squared. And again, you didn't say move it left to right or up and down, right? So nothing's changing. All we're doing is throwing a negative sign up out in front, okay? The graph shows g of x, which is a translation of f of x squared. Write a function rule for g of x. Well, it would normally be here, right, at the origin. And what happened? It moved down 1, 2, 3, 4, 5. So it didn't move left or right at all. It just moved down 5 spaces. So h, we're not messing with. All we need is k, right? H moves it left and right. It didn't move left and right. K, we're going to just move it down 5 spots. What are we going to say? X. Again, you could say plus 0. In fact, you could leave this out of the parentheses, but for now, let's stick to the protocol. And k, we moved it down 1, 2, 3, 4, 5. So we're going to say minus 5. Okay. Again, find g of x, where g of x is a translation 1 unit down. Again, all we're worried about is the down part. We went down 1, so h didn't change. We went down by 1. Okay, 4 units right. Well, right is in the positive direction, so we need to say that is the opposite. Okay, again, nothing about moving up and down. You just leave it right there. Okay, let's take a look at this one. It should be here. It moved 1 to the left, right? So that is to the left is in the negative direction. We have to flip that, not to be -1, but to be +1. So we're going to say x plus 1 squared, and that's it. Okay, we can leave it just like that. There's nothing to add. It didn't move up or down, so nothing for k, and we'll call it a day. Okay, so again, you guys should be able to take this. I'm going to go to the next level, and that's about it. Okay, those are the only types of questions they're really going to ask you. So how are you going to translate it? Again, h and k are going to do your location of vertex. Left and right is going to be h, just remember it's flipped, and k is going to be up and down.